So we are talking about the last ice age and how we came out of it, and our ancestors lived through it, and many of the other animals also lived through it. This woolly mammoth, the saber-toothed tiger, and cats, and so on and so forth. But ice age doesn't mean it's constantly getting cold and colder. It means it is getting colder and colder, but sometimes it warms again and it comes back and gets colder and warms and so on and so forth. So even in ice ages, there are warm and cold climates. That sounds confusing, but it is true, kids. A lot depends on Earth's orbit, the way it circles the sun, of course. Sometimes during an ice age, the shape of the Earth's orbit keeps it further from the sun year round, and the climate grows colder because you are getting less energy from the sun. These times are called glacial periods. When Earth's orbit changes shape, bringing it closer to the sun, the planet warms. These times are known as the interglacial period, where inter in Latin means between. So interglacial means between two glacial periods or between two ice ages. So now are we between two ice ages? You may ask, Grandpa, last ice age ended 12,000 years ago. Are we heading into another ice age? Well, kids, according to orbital mechanics, how the orbit changes, we can exactly predict where we should be going. And we should be cooling now, but as we said before, we are burning fossil fuels, increasing greenhouse gases, and we may be delaying the next ice age. But in the meantime, let's look at what the Earth's orbit does. Of course, there is the sun, and Earth orbits around the sun in its elliptical orbit, but how elliptical it is. Remember, ellipse is basically like a squished circle. It can be more squished and less squished, and if you're older, you know that there is a minor axis and the major axis and so on. So the eccentricity of the circle, the orbit shape, changes on 100,000-year cycles, which means it comes closer during 100,000 years and slowly moves away from the sun during 100,000 years. And if you're away from the sun like Mars, then your energy received from the sun itself decreases, and that happens, then maybe glaciers grow. And what happens when glaciers grow? Albedo goes up, so then you will get colder. The ice albedo feedback can kick in, and then you can begin to freeze. So changes in eccentricity are here exaggerated, so the effect can be seen. It doesn't vary so much in reality. Earth's orbit shape varies between 0.0034, so that's almost a perfect circle, to 0.058, which makes it slightly elliptical. So it changes by a tiny amount. But why is it important? Because even a tiny amount of change in the energy can start to create ice albedo feedbacks and amplify the small change in sun's energy, whether it's increased energy that is melting the glaciers or decreased energy that is building the glaciers, because ice albedo feedbacks work in both directions. And the Earth is also changing its tilt to the orbital plane. Remember, in the current period it's tilted at 23.5 degrees, but over 41,000-year cycle it becomes 22.1 to 24.5 degrees of tilt. When it tilts, what happens? The total amount of energy coming from the sun doesn't change because your distance is not changing, but the pointing towards the sun and pointing away from the sun is changing, which means the winters and the summers can get very different. So the distribution of sun's energy from the north to south decreases, which again can kick in the ice albedo feedback of building glaciers and melting glaciers. One other thing happens, Earth's axis also precesses. You may have played a top as a kid, or you may still be playing. When you throw the top when it's high speed, it's rotating very fast and it's upright. As it slows down, it begins to wobble. So because of the gravitational pull of the other planets in the solar system, Earth also wobbles like this. It is called the axial precession, which happens on 26,000 year cycles. There is another precession which moves the orbit itself. In what way? Now there are calendar times when the equinoxes happen, when the sun is on the equator and day and night length at every latitude is the same, and there are solstices where there is a summer solstice and the winter solstice. There is the autumnal equinox and a spring equinox. These things keep moving, so unless we adjust the calendar, they will not happen at the same time. When do they happen now? In March and September and July and December. You can look up the exact dates that happen when these equinoxes and solstices happen. So all these things together, they change ice albedo feedbacks, and the guy who first did the mathematical formulation is a guy called Milutin Milankovitch from the Austro-Hungarian Empire at that time in the 1700s and 1800s. Before him, James Kroll had also suggested the same thing, that these things happen in science, where somebody discovers something and another person discovers it again, because before you didn't have internet, you didn't have social media, you didn't have newspapers going around the world, you didn't have flights and ships and so on and so forth, so people didn't know necessarily that somebody had already found the same thing. But anyway, when you combine all these energy changes coming to Earth, you can have temperature changes happening like this. You have, believe it or not, right now we are in a warm interglacial period of an ice age. So we were in an ice age that ended 12,000 years ago. So if you think this is the past and this is the present, we came out of the last ice age and we warmed through the Holocene, but we should be beginning to cool if this cycle is still working because of orbital changes in obliquity, ellipticity and precession. But global warming is happening, right? So when it gets colder like this, it is called the glacial period. When it warms up like this, called interglacial period. And there are reasons which are a bit complicated, but if you're old enough, you can follow up on my other channels on podcasts on why the warming from cold to warm or glacial period to interglacial period seems to go so fast. But when you are cooling and going from warmer to colder, it seems to take much longer. You can see that warm and cooler, warm and cool. So many points to be made there, but mainly remember ice albedo feedback is working whether it's warming or cooling, because here you are melting glaciers, albedo is decreasing, more energy keeps in the system, it warms more glacier melts and so on. And when you start to build glaciers, albedo increases, more energy is reflected coming from the sun, and it gets colder and you get more glacier and more albedo and so on. And somehow it ends at some point because orbital forcing changes, energy changes again and so on. So here is the last piece of this chapter. Dr. Joseph Romm, well-known climate expert, has written that he and the world's top scientists have confidence based on their detective work that right now the long-term trend for Earth, driven largely by changes in our orbit, should be a very slow cooling, just like it has happened in the past, most recently from about 135,000 years ago to about 12,000 years ago. Okay, Earth should be cooling, not warming the way it is. So something is clearly off. Something seems to be clearly off. Also, another weird thing is happening. In the past, each of the climate shifts took place slowly over millions of years. This time everything is happening much quicker. It's almost like pressing a fast forward button on the climate system. How do climate scientists explain this great acceleration of warming, and who push the fast forward button? You know the answer. We are burning all these fossil fuels and increasing the greenhouse gases in the atmosphere and trapping all this thermal energy that is trying to escape to space, and We are melting glaciers because of that warming resulting from increasing greenhouse gases, and the ice albedo feedback is kicking in. And remember, when we are melting glaciers, it goes very fast. So we are doing the we came out of the last ice age naturally, orbital changes, but then we started to do climate change or global warming, which is accelerating the warming and potentially stopping the slow cooling that should have started if we were in a natural cycle. So that tells you a lot about the past climate changes and how it happened and how life evolved and how life affects climate and how life, climate and earth have evolved together, and now we are making a big change by ourselves, and we have to now figure out where we are headed because of what we are doing, and we'll continue to discuss those things in the coming podcasts. Okay, see you in the next podcast and next chapter. And remember, if there are questions, you can send me or ask your parents, teachers, siblings, neighbors, grandpa, grandma, and friends also, and so on. Okay, see you.